Alright, so we're getting into lesson 1.5 today, and we are looking at infinite limits. And we talked a little bit about this in our last video, as far as just sort of testing signs to see whether you're approaching a positive infinity or a negative infinity. Remember that having an asymptote in your graph is what's going to cause you to see those infinite limits. So that's kind of the first thing that we're looking for here. Is if you look at a function like this, where you have x minus 4 as your denominator, we could not do direct substitution on this with 4 since it would create that 0. So we see this as a vertical asymptote. So on either side of this is where we're going to see potentially a positive or a negative infinite limit on those guys. So let me give you two quick images here on page 101. So both of these graphs you can see have a vertical asymptote where x equals 1, right? But on the first graph, they're both headed towards positive infinity, whereas the second graph, as I approach 1 from the left, I'm approaching positive infinity, but as I approach 1 from the right, I'm approaching negative infinity. And so obviously if you have the graph, super easy to see what you're approaching on those. But without the graph, we need sort of a different way of checking to see what we're approaching here. So easy way, just by testing these signs, we can tell what we're approaching. So if I was just given a function like this, and we can see that the asymptote is at x equals 4, I would need to check, as I approach 4 from the left, what do my signs look like? And as I approach 4 from the right, what do my signs look like? So as I approach 4 from the left, you can take any number less than 4 and plug it into this and see what kind of a sign that would create. So if I take a number less than 4, say 3, and I plug it in for x, that's going to create a negative on bottom. According to this, the numerator is always negative. So in this case, as I approach 4 from the left, a negative over a negative is going to tell me that I'm approaching positive infinity. If we were approaching 4 from the right side, pick any number bigger than 4, plug it in. You can see that would create a positive on bottom. So now I'm looking at a negative over a positive, which is going to give me my negative infinity limit as we approach 4 from the right. Really easy to see on the graph. If you were to graph this guy, this is what it would look like. So clearly approaching positive infinity from the left of 4 and negative infinity from the right of 4. All right, so let me jump down to these. Pretty similar idea for this one. One thing you got to take notice on these, though, is keep in mind that if you have a factor that cancels out like this one, that was not an asymptote. That was a hole in the graph. So you're not going to get the limits that approach infinity with holes in the graph. You're going to get them with an asymptote. And so recognize that this guy canceled. This is all you would have left. So this is where the vertical asymptote is coming from, at x equals negative 2. So the limit as we approach negative 2 from the left and from the right, again, I'm just testing signs to see what that would look like. So if I pick a number to the left of negative 2, like negative 3, and plug that in for both of these x's, you'll notice that it would create a positive on top but a negative on bottom. And so that would tell me overall I'm approaching negative infinity. If I picked a number bigger than negative 2, like negative 1, as you plug that into both of those would create positive results. So that means overall we are approaching positive infinity for that one. All right, let me jump over to the next page. So before we go through these last couple examples here, let me show you these properties on page 104. These are actually really helpful. So as you look at these guys, here's what this is saying. The f function is approaching a limit of infinity, positive infinity, and the g function is just a basic limit, like any basic value constant limit. Couple things you can do with these. If I were to add them together, well, infinity plus any constant is still going to be infinity, right? So keep that in mind. If either one of those would be in infinity and the other one is a constant, when you add or subtract, it's still going to be infinity. As their product, when you multiply them together, if the limit of g is positive, then overall it's going to be positive infinity. If one of them was negative, that's what this is saying, then overall you have negative infinity for your limit. And this is a big one too. This one comes up a lot. your f of x function, which is infinity, if you have infinity on bottom, remember what happens to a fraction as the bottom value gets bigger and bigger and bigger, your overall value becomes smaller and smaller and smaller, right? As you go from, say, a fourth to a fifth to a sixth to a seventh to an eighth, overall you're getting a smaller and smaller decimal when you do something like that. So if my overall value is getting smaller and smaller and smaller, then we are approaching 0 in a case like that. Okay, so let me show you a couple of these with some real numbers in there. So I have two things that are being added together. So as we just saw, I can separate these two things out. So this would have been like the g of x function. This would have been the f of x function. And so if we separate those out, I can say the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x squared. So we're separating these into two different statements. So that's what you're seeing right here. Well, the limit as x approaches 0 of 1 is always going to be 1. No matter what you're trying to approach here, if my function is just y equals 1, it's always going to be a result of 1. So that's for the first part of this. In the second case, 1 over x squared. As you approach 0 would have to be infinity. There's a couple ways to look at this. You could always go back to your basic number testing. I could see as I approach 0 from the left and as I approach 0 from the right, what am I getting overall? If I start plugging in numbers to the left of 0 like negative 0.9, negative 0.99, negative 0.999, start getting values that are closer and closer to 0. This overall would become smaller and smaller and smaller because they're being squared. Therefore, if the bottom of your fraction is getting smaller and smaller and smaller, right, overall, your overall value is becoming larger. And so it's approaching positive infinity. It's really easy to see with a graph. If you were to graph 1 over x squared, it looks like this. So you can see as I approach 0 from the left, I'm approaching positive infinity, and as I approach 0 from the right, I'm approaching positive infinity. So we're getting positive infinity for this one. So if I add the two together, 1 plus infinity is just going to be overall positive infinity. Let me give you one right here. So this one was specific to just as I approach 1 from the left of this function right here. And again, we're basically separating out these two functions. I need to see what am I getting as my limit for the numerator, what am I getting as my limit for the denominator, and then piece those ideas together to see overall what is that becoming. For the numerator, I can use direct substitution, right? So I can plug in this 1 in for this x right here, right? And so that's what you're seeing on this. And so if I were to do direct substitution on top, I get a limit of 2. So that's going in right here as my numerator limit. As far as the bottom goes, I cannot use direct substitution because if you put a 1 in for this, the cotangent of pi is undefined. As you can see right here, right? There's an asymptote right there. So it's undefined at pi, it's undefined at 0. So I can't use direct substitution on that. So this is where I just need to do some number testing or take a look at what that graph is looking like. So on this one, as x approaches 1 on this, you can see our graph is going to be approaching negative infinity as we approach 1. If I did my traditional pi over b in order to see what the period looks like, it would look like this. And so I know for this particular graph, the period is going to go from 0 to 1, just based on that statement right there. And so if I understand just what that graph looks like, I can see as I approach 1 from the left, I'm approaching negative infinity, right? And so this is what we're getting for the limit of the denominator. And so overall, if the denominator is approaching negative infinity, my limit must be approaching 0. Let me give you a real number example here so you can kind of see why. Right, so I got the 2 on top. These are becoming bigger and bigger negative values. So if I did 2 divided by negative 1, negative 10, negative 100, negative 1,000, as I put bigger and bigger negatives in there, well, look at the results that we're getting on this, right? It's getting closer and closer and closer to 0 as this goes on. So that's how we know our limit on that is approaching 0. All right, one last example here. So this is the limit as x approaches 0 from the left. And again, I have two different functions being added together, so we're simply going to separate those guys out and deal with them separately. So we're going to start as the limit approaches 0 from the left of x squared. So again, think of the graph on this. I think graphs really help with our understanding of the limits on this, of what we're approaching. Here's the graph of x squared, right? As I approach 0 from the left, you can see that I'm getting closer and closer and closer to a y value of 0. Now this one you could just do direct substitution on. You wouldn't need the graph for this, right? This is the one you couldn't do the direct substitution on. This one's fair game, so I could just plug in my 0 right here, and I get that 0 for my limit. On the other one, I can't do direct substitution, so again, I either need to have an understanding of what the graph for 1 over x looks like. I think the graphs are really helpful. Or if I don't have the graph and I can't use direct substitution, the other option is number testing, right? I can take numbers to the left of 0 and start plugging them in. So I could test negative 0.9, negative 0.99, negative 0.999, and as I plug those guys in, everything to the left of 0, I can see I'm going to get bigger and bigger and bigger negative answers as I get closer to 0, right? And so that's why we can see on this one we are approaching negative infinity to the left, from the left of 0. So if we piece those things together, I'm looking at a limit of 0 plus a limit of negative infinity. Well, obviously if you add those together, right, overall we are approaching negative infinity. So that's it for 1.5. Again, this is some tough stuff. I wish we were doing more of this in person in class so we could ask questions and do some of this together, but this is just kind of what it is for now. So, but still, if you're still having any of the issues on this, or if any of that's not clicking for you, just let me know, and we'll see what we can do to help you out.